Hi class, welcome to lesson 39. At the end of this lesson, you should be able to distinguish between molecular and empirical formulas and determine the molecular formula based on molecular mass and empirical formula. Let's get started.
Because atoms and molecules are so small, it can be very difficult to determine the exact molecular formula of a compound. It is, however, quite easy to determine the empirical formula of a compound in a lab. We learned about empirical formulas in the last unit, bonding. The word empirical means based on evidence. In science, that means based on evidence from a lab. An empirical formula is the information you can gather about a compound in a lab. It is the formula with the simplest whole number combination of elements for that compound. A molecular formula is the actual combination of elements for a compound. We cannot determine molecular. So when we look at empirical formulas, we know the simplest way to form an empirical formula is to divide all the subscripts by the greatest common factor. Ionic compounds are always reported with formulas that are empirical. So if we take a minute to look at the ionic compound formed between iron and oxygen, in this case iron has the oxidation state of +2, when we apply the crisscross shortcut where we cross the oxidation numbers and not the signs, we get Fe2O2. But we can simplify this to 1 iron and 1 oxygen. The simplification works because the goal of making an ionic compound is to have the total charge equal to 0. When we have 1 iron plus 2 and 1 oxygen minus 2, our total charge is 0. The same holds true for aluminum phosphate. When we have 1 aluminum and 1 phosphate, we already have a total charge of 0. So there is no need to use the crisscross trick. Covalent molecules can be simplified to an empirical form, but they are not always simplified. So here in this example, you can see that we begin with the formula C2H8. If we simplify the formula by dividing by the greatest common factor, we get an empirical formula of CH4. The next formula, the molecular formula, is actually C3H12, but its empirical formula is exactly the same as the different molecule above. Now it is time for you to try some practice. Look at these formulas and see if you can determine the empirical formulas. Did you get them right? Notice how the ionic formula for barium chloride remains the same because ionic compounds like barium chloride and calcium phosphide are always written as empirical formulas. Sometimes molecular formulas can be reduced to empirical formulas, meaning that a molecular formula and empirical formula can sometimes be the same, but not always. The molecular formula is the true proportion of elements in a covalent molecule. You can use empirical formulas and a given molecular mass, also known as a gram formula mass, to determine the true molecular formula of a compound. In order to do this, you have to follow 3 easy steps. The hardest part about these steps, though, are they are not on the Regents chemistry reference table, so you have to know what you are doing. First, you will calculate the gram formula mass of the empirical formula. Then you will divide the molecular mass, which is always given in the question, by the gram formula mass. Then you will receive a multiple. You will multiply all the subscripts in the empirical mass by the multiple in order to find the molecular formula. Let's try some examples so you can see what we are talking about.
The empirical formula for
So in this problem, we are given the empirical formula of ethylene and its gram formula mass. In order to find the molecular formula, we will first find the gram formula mass of CH2.
Step 1 is done. Step 2,
This is
divide the
14
molar mass by
grams.
the empirical formula.
Then we'll take
It
the
says
given
in our
molecular
problem,
mass,
find the
you can
molecular
see it in the
formula
question, it's
if
given to be
the
28,
molecular mass
and
is
divide
28
that
grams per mole.
by the
That
empirical
means
mass
you
of
take 28
14.
grams, you divide
That
by
means our
14
multiple
grams.
is
That
2.
means you take the
So the molecular
mass
formula
divided
is
by the GFM,
found
and you
by
get the
multiplying
multiple
each
The
subscript
multiple
of the
2 means you
empirical
take
formula
empirical
by
formula,
2.
which is CH2, and you
This
multiply
gives
all
us the
coefficients by
molecular
2,
formula
which means you
of
get C2H4. That is
C2H4.
our molecular formula. So
In
to
this
check
case,
yourself, you
our
can say
work
that 2
checks
carbons,
out.
which is 24,
So to
plus 4
check
hydrogens
yourself,
is
what
4.
you can do
24 plus
is
4
find
is
the
28,
gram formula
and
mass
that is
of
also
the
our
molecule
given molecular
and
mass.
see if it equals the given gram formula mass. Now take a minute to pause the video and try this practice question. Go ahead, pause the video, use your Regents Chemistry reference table, the periodic table, and your non-graphing calculator and see if you can solve this question. So you can see our empirical formula mass is 31, which gives us a multiple of 3. Our final formula becomes C3H9O3. When we check to make sure that the mass of our molecular formula equals that of the empirical, we can see that we were correct. So as a summary, you can see that an empirical formula is the simplest ratio of atoms that combined to form a compound, while the molecular formula can be a multiple of the empirical formula, as it is always the actual ratio of moles of atoms in a compound. Make sure you complete your Google Classroom homework and bring all your questions to class. See you soon!